here's a walkthrough on how to use QGIS to make a contour map. In this example, I'll be using some geophysics data from a lateral profiling resistivity survey. So before we go into QGIS itself, on the top left, I have a data formatted in Excel. So what you see here are actually 45 data points. And these data points are actually spaced 100 meters apart in the real world. So we have one line with data going in the easterly direction. So 5 lines, 100 meters apart in spacing, going towards the south with survey points 100 meters going from west to east, from 1E to 9E throughout the survey. So what I've done is I've taken this data and I reformatted it into an easting and a northing and resistivity information. And essentially in doing that, what you're doing is you're defining a X, a Y, and then of course a Z parameter. In this case, it's resistivity that's going to be contoured. I also included another column for ID, just so at a quick look, I could find which any of these points are within its spatial plot and determine them on ID other than just XY coordinates. I have this saved as a CSV file, so that is absent of all the formatting that gets saved when you make an Excel file. And I have it going from the first line, which above would be 1S. I just called it 0 northing. It's my baseline of data from 16 to 34. And then the subsequent line is just 100 meters down towards the south. So that would be line 2S. So again, that's my Y variable. And then my X variable going from 0 to 800 meters. So that would be 1E to 9E with its resistivity information, so on and so forth. So it's very important that you are very methodical in how you organize your data for QGIS or Surfer or any other contouring program to be able to import. Okay, so I've saved this as a separate file, as a CSV file, and I will import this later on into the software. QGIS itself, just go to QGIS.org or search Google for QGIS. This is free open source software, so you never will have to pay for it. When you come to the landing page, there's typically a couple versions that are offered. I like to go for the LTR version, which means a long-term release, which means it is the most stable version to a point that will be supported for typically 5 years in the future. But of course, like all other software, it gets continuous improvements because it, again, is open source. It is sent out to the community to vet for any bugs, etc. Has a newer version, but again, it's not a stable long-term release. But for this example, I'm just going to download the long-term release. And I actually already have. You have a couple of options, but download whichever version that you're comfortable with. Now that you have QGIS downloaded and you've run the application, we have to do a one-time installation of a plugin. That plugin is going to allow us to make contour maps. So within my menu toolbar, just select Plugin, Manage and Install Plugins. And I will get a list of all available plugins that are available to me. And again, it's in alphabetical order. You could search by typing in contour, which I have here. And go ahead and install it. Now, I've already installed it on my system, so your option will be a little bit different. You will have an option to go ahead and install the program. And again, once you've done it once, you don't have to do it again. Okay. So first thing that we have to do before we contour is to bring in some data. So here, this little icon on the upper left-hand side, that's the data source manager. We're just going to click open. This is where we're going to import our CSV file, and already QGIS is looking for a comma delimited text. So basically an unformatted text file, which our CSV file will be. So I'm just going to search my desktop for the file, and there I have it, Lab3 QGIS. And of course, this is my personal computer I'm recording this on. There is the file that I brought it in. It's going to create a new layer called Lab3 QGIS. If I wanted to rename it, I can rename it whatever I wanted at this point, I suppose. It reads it as a CSV file, comma, separated values. And it shows the sample data right down below here. And it's already defining an easting and a northing. So the X field is this field right here. That's my X data. My Y field is a northing, but it hasn't assigned anything to actually plot yet. So I'm going to tell it the Z field in my X, Y, Z coordinates to plot resistivity. And again, it gives you a sample of the CSV file. It's only showing the first 20 data sets, again, just to allow you to make this X, Y, Z selection. If you don't have anything under coordinate geometry, then you could just put the default WGS84. That's fine. We're not going to actually put real world coordinates to this text anyways. Click on Add, close, and there are our points. So my line 1S, 2S, all the way to 5S, and my 8 different data points. If you wanted to, you could click your left mouse button and move it around. You can make it smaller or larger by going up and down on your scroll wheel. Or if you wanted to reset the view, if you get all lost, just go to zoom full and it's going to take you back to the full screen. Now we can see here by default it has assigned each of these points a green dot. If I wanted to go ahead and edit how these look, I could do so right here by just left clicking on this layer, and it'll bring up the layers property. And right now there's no labels. If I wanted to label all those to see what the data actually looks like, I could select single labels. And right now it's just going to show what the ID is, the number that was in the A column. Maybe I just want to see what the resistivity values look like. And I could do some orientation and some font changes here and text and whatnot. Anyways, I'll just apply that, and then I can see my raw data right there. Okay. So we know that our data came through and our grid looks okay. So let's go ahead and slap some contours on it. So I'm going to go into Vector, select Contour. It's going to make a new layer based off of this previous layer. So that's going to be my input. What do I want to contour? I want to contour resistivities. Okay. I could have contour lines. I could have filled contours. So that's going to be a gradation or a color map of the contours. Or I could do both. Let's just start with maybe contour lines. I could do a fixed contour interval, and maybe I'll just leave it at 1 for now. Contour interval of 1 ohm meter. And I get a preview of what these different intervals would look like from a minimum and a maximum value of 14 to 38.8. And again, all that's happened is QGIS has scanned the CSV file, and it will assign the minimums and maximums by themselves. If you only want to contour maybe between a certain amount, I'm not sure why you'd want to, you could define your own minimum and maximums here. And then it's going to make an output layer. So the input layer was Lab3 QGIS just for the raw data points. It's going to make a new layer called Lab3 QGIS _ resistivity. And again, you can make it whatever you want to. You could change it to whatever you want to. and so on and so forth. Okay. You can also change the precision of how many decimal places you want to be show on your contour map as well. I'm just going to leave that as 0. And I'll just go ahead, add, click on add, and I can close this layer. And quite simply, there's my contour map. Okay. So one thing you'll notice is the contours themselves are not labeled. Currently, only the individual points are labeled. So we could go ahead and we could change that. So first of all, let's go back to our original layer, the Lab 3 QGIS point layer, and bring up the layers properties, the label properties, and just change that to no label. Okay, so by default it was what we had changed it was to single labels. Plotting ID, we'll just change it to no labels, and we hit apply, and that's just going to basically get rid of the identification numbers or the resistivity values, I'm sorry, that we had plotted. Now I could go ahead into this menu or this layer, the line layer, and I could establish contour numbers on that, give them each labels instead. So double click on that layer, click on labels. It's already been defaulted for me. Change it to single labels. Again, I could change the text size. Maybe I'll make it a little bigger, 12-point size. Do apply. Okay, and now my contours are labeled. Okay, so if I want to make this look a little bit more readable, I could fill in the color map. So instead of having green lines to red lines, for low values to high value, I could use a color shading also. So I'll just go into the vector menu, into contour again, making sure that I am selecting resistivity. I'm going to have, there was an option here for contour lines or filled contours, so I will do both. Again, establish a contour interval. Again, we're always looking to make sure that we have a preview of the data, so it's reading our data file correctly. What's the output layer name? I could go ahead and just leave that as a default, hit add, and close this menu, and then I'll get something that looks like this. Okay, so you'll see that it actually added another layer here for the colored contours. Again, if I want to turn that off and turn it back on, I sure can. You can turn any of these layers on and off accordingly. Okay, now this map is acceptable for the geophysics class in order to do a quick field map, sometimes called a quick look. Thank you.